All right, finally, a problem worthy of your talented and giftedness. Okay. What's going on here is obviously we've got to figure out the weight of these masses, and the weight of those masses will exert torques. Okay. Now, what we do is we say this, the box, right? Let's look at the torques. We're going to torque about this point, right? So we pick this as our torque point, right? This box is going to exert a force downward, right? That is 16 times 9.8, right? So when I say G, I mean 9.81 newtons per kilogram, right? Okay. So that force is going to be 16 times 9.81, not grams, that's G, like as in 9.81, right? And it's going to be at, it's 2 meters from the left side, so 2 meters. Right, so we got that figured out. And this is going to be a positive torque, a clockwise torque, right? All right. Next, we have the beam itself. The beam is 42 kilograms and is 6 meters long, right? So now the question is the weight of the beam. Where do we say the weight of the beam acts, right? Does it act all on the left side? Does it act all on the right side? Or does it maybe act right in the middle of the beam? And of course, this is what we do, right? We say that the weight of the beam acts at the center. So here we've got a force of 42 times 9.8, right? That's what the G is, right? And that's at 3 meters. Why is it 3 meters? Because the beam is 6 meters long. 3 meters is the center, right? The center of the beam. Now we know that. This is, by the way, something called the center of mass of the beam. We know it's the center because this beam is uniform. Okay. It also looks very uniform, doesn't it? It's an even shade of gray, right? Okay. So this acts at the center of the beam. This force here is acting at 4.1 meters, right? And then this person, and I'll always do this for you. Okay, it's my kind of my mark of pride, right? The force of gravity acting on this person is 71 times G. And notice I said that they're 1 meter from the right side. Well, you don't give a hoot how far it is from the right side, right? You care about how far it is from the left side. Well, so let's see, it's 6 meters long. We're 1 meter from the right side, so we're 5 from the left side. At 5.0 meters from the left side. Right? All right, so now we are ready to set up the mother of all torque expressions, right? So let's just go, this guy, by the way, is going to be an anti-clockwise torque. Right? All of these other torques, the ones acting down, will tend to rotate the beam clockwise. So if we do our torque expression, it looks like this. Okay, we have positive 2 times 16G, and the G is 9.81 again. I'm just too lazy to write it all out. The expressions don't look nice if you do that. And then I've got positive 3 times 42G. That's the beam, right? Right, so that's the center. Center O mass of the beam. Right, so the beam is 6 meters long. The center would balance at its center, which would be 3 meters, right? Then we have this unknown force, right? So minus 4.1 times F. And then finally the person, right? Plus 5 meters times 71 G. And all of these G's are 9.81s, right? Okay, and then that adds up to 0, right? All right, we can do the math. So I'm going to do this. Let's go. Basically what I'm going to do is I'm just going to, all the things that don't have F, I'm going to add all those up and then just divide by 4.1. Okay, so I'm going 2 times 16 times 9.81 plus 3 times 42 times 9.81 plus 5 times 71 times 9.81. I get quite a large number, 3,809, and I'm going to divide by 4.1. And I get the wrong answer. All right, how did I get that? See, 3 times 16 times 2, and let's see, 3 times 42. Oh, I see what to do. I inadvertently divided by, okay, hold on. Okay. Let's do that, and then divide. I get 5,032, and let's divide that by 4.1, and I get 1227. So force is 1227.4 newtons. All right, there we go. As long as you don't divide by one of those g's instead of multiplying. So then we only have, I guess, 3 sig figs, so I guess we'd have to say about 1230 newtons, okay? So again, what you want to do is you want to figure out, I think it's good to draw a force and figure out where all these forces act, okay? You know, eventually you're going to get to the point where you just write this equation down, right? Consciously decide how far from the torque point it is, right? And then write it down, express that, right? And then remember, this expression here is just torque is R times F, right? And then these are all, 90 degrees with it. So the sine theta, that part is just 1. Sine of 90 is 1, right? So RF, RF, RF. At least one of the torques has to be anti-clockwise, right? Or it can't add to 0, and there you go.